Dear students, welcome to our online class. The topic of this class is length of a plane curve, which is also known as arc length. So what does it mean by length of a plane curve? Let's draw a curve. We want to know the length of this curve from one end to another end, x equal to a to x equal to b. So the arc length of a plane curve, also known as arc length, and the length of this curve along this line from this point from one end to another end is called arc length. So the question is, how can we calculate arc length of a plane curve like this? And we know a formula, there is a formula to calculate arc length. Arc length is denoted by capital L. So by the help of integration we can calculate it. 1 plus d dx square root. If you have a curve like this, y equal to fx. So now the next question is, where this formula comes from? How can we derive this formula? This is what we want to discuss in this lecture. And the length of this curve, you can first break the curve, like let's say, let me discuss it here first. Suppose I want to calculate the length of this curve. So the length, is it the distance between A and B of this curve? It's not. But if you break this curve or divide this curve into a point here, C, then the length will be, if you add AC and BC, then you will get better result. And again, if you break here and here, then the length of the curve, is it EF AE plus EC plus CF plus FB will be better result. So the shorter line segment will provide us better approximation to the arc length of this curve. So this is the basic idea. If you consider the line segment, if you break this curve into n line segment and then sum up all those line segments, then you will get the arc length. So it will be your approximation. Let's say L equal summation of, if you can divide, let's try to calculate the arc length of this curve from x equal to a to x equal to b, and if you break this line at several points like this, okay, like this, and if you then add those line segments, then you will get the arc length. So the line segment, let's say the length of this one, let me zoom it. The magnification of this one will be something like this. Let's say it will be something like this. This the magnification of this part. And we want to know the distance from this point to this point. Let's say this point is at x equal k minus 1 and this point is at x equal k. So the change of x, let's say delta xk, and change of y, let's say delta y k. Now we want to calculate this length, the length of this line segment. Let's say this one is LK. So the total arc length from here to here will be sum of all these small line segment, and we are calculating this one LK, and K equal to 1 to N. Suppose we have N line segment here. So this one is the approximation of arc length, and the large N will be the more accurate result you will get. So suppose if N equal to 5 and N equal to 10, then for N equal to 10 you will get the better result. If N equal to 500, you will get more good result. If N equal 1000, then your result will be better than the previous one. So let us try to calculate LK. How can we calculate LK? By using Pythagoras theorem, in this triangle we know LK is equal square root of delta xk square plus delta yk square. And what does it mean by delta x? We know delta xk is equal difference between these two xk minus 1, and delta yk is equal fxk. Here it is fxk minus 1, and at this point is fxk. So delta yk is equal fxk minus fxk minus 1. So now one can easily understand that this line is called a secant line, and the slope of this secant line will be what? The slope of this secant line will be the same as the tangent line. If you draw a parallel line and move it this side parallel line, then at this point you will get a tangent line. So the tangent line, let's say here x equal x star k. So at x star k you will get a tangent line, and this one is a secant line and this one is a tangent line. And there is a theorem which is called mean value theorem. Mean value theorem, it says the slope of this secant line is equal to the slope of this tangent line. So how can we calculate the slope of this secant line? The coordinate, the change of y, it means this delta yk divided by delta xk. This is the slope of this secant line, and we can write it fxk minus fxk minus 1 divided by delta xk, which is xk minus 1, which is equal the slope of this tangent line, and the slope of this tangent line is nothing but the derivative of f at x star, xk star. The slope of this tangent line is nothing but the derivative of f at xk star. And note that xk star is a point in between xk minus 1 and xk. Xk star is a point if in between xk minus 1 and xk then the slope or derivative of fx at this point xk star is the slope of this tangent line. So we can write this equal, we can write f prime xk star. This is the mean value theorem. So from here we can write this one. We can write, it means delta yk is equal delta xk times f prime xk star. So this is the mean value theorem. So we can put this value here in this equation. So I will get L equal, L is approximate to summation of k equal 1 to n, here Lk, and Lk means this square root of delta xk square plus delta y is this f prime xk star times, so since it's delta y square, so I can put here square times delta x k square. So this one I can write, you see delta x square, delta xk square and delta x square, we can take it out of this square root, summation of k equal to 1 to n, square root of 1 plus f prime xk star whole square. So this delta xk square, if I take out of this square root, then I will get xk delta xk. Now the Riemann integral will be what? The Riemann integral will be, if I put a limit max delta xk tends to 0, and max delta x tends to 0 is nothing but n tends to infinity. When n tends to infinity, then max delta xk will tends to 0. So I can take limit any one of them. Let me put here max delta xk tends to 0, summation of k equal to 1 to n, square root of 1 plus f prime xk star whole square times delta xk, and the corresponding integral will be this is the approximation, but if you put the integration, the definite integration, from the definite integration we have a relation between Riemann sum and the integral, which is called Riemann integral sometimes. So L equal integration from here x equal a to x equal to b, 1 square root of 1 plus f prime x whole square dx. This delta x k will convert it to dx. So you see this formula is nothing but our arc length formula, x equal to a to x equal to b, 1 plus d dx square dx. So now I think you understand where this formula comes from. This is how we can calculate arc length of a given curve. If your curve is y is a function of x, let's say this is our arc length formula 1, and there are another formula if your curve is let's say x equal to zy, then this arc length formula will be with respect to y equal to c to y equal to d. If gy is a smooth curve on the interval a to b, on this interval, sorry, c to d, then arc length formula will be y equal to c to d 1 plus dx. This one you can write dy dx. So here I can write dx dy square root of dy. This is our second formula, and there are another formula for the parametric. So if the formula 3, if your equation is given like x is a function of t and y is another function of t and t is in between a to b. So here x and y, they are represented by a parameter, and these equations are called parametric equations. Parametric equations, for example, parametric equation of a circle will be x equal to r cos theta and y equal r sin theta. Here x is a function of theta and y is a function of theta, and from here we can write x square plus y square equal to r square. So we know it's a circle in rectangular coordinate system, but this is a circle in polar coordinate system, and these equations are called parametric equation. So for a parametric equation we can also calculate arc length, which is integration will be on t equal a to t equal b dx by dx dt whole square plus dy dt square root dt. But of course dx dt and dy dt should be continuous within this interval. And here the function y equal to fx should be a smooth curve and continuous. It means continuous on this interval ab. And for the second one, this function should be continuous on CD, and this case this one and this one should be continuous on this interval. So these are the formula in order to calculate the arc length of a curve. So now let us try to understand how can we calculate arc length by using this example. Example 1, it says find the arc length of this curve y equal x to the power 3 by 2 from 1 1 to 2 root 2 using our two formula. The first one was integrating with respect to x and second one was integrating with respect to y. So we want to calculate arc length of this curve from 1 1 to this point 2 to root 2. This is the graph of this curve by using two formula. So let us first evaluate the first one, which is a, and for a we are going to use this formula, integrating with respect to x. So x equal a2, x equal to b 1 plus d dx whole square root of dx. So here our function is this one, y equal x to the power 3 by 2. therefore dy by dx will be 3 by 2 x to the power 3 by 2 minus 1, which is equal 3 by 2 x to the power 1 half. Therefore the square root of d dx is equal 9 by 4x. So let us put this result here, and x start at 1 and end at 2, so the limit will be 1 to 2, square root of 1 plus 9 by 4x dx, and it's a simple integration. We can evaluate it by using u substitution or z substitution. Let us consider this one is equal to z, therefore 9 by 4 dx equal dz and dx equal 4 by 9 dz, and the corresponding value of z will be, when x equal to 1, z equal 1 plus 9 by 4, which is 13 by 4, and when x equal to 2, z equal 9 plus 18 by 4, which is equal 22 by 4. So let us put this result here, 13 by 4, 22 by 4, 1 square root of z, and dx equal 4 by 9 dz, which is equal 4 by 9 square root integration of z to the power 3 by 2, 2 by 3, 22 by 4, 13 by 4, which is equal 8 by 27, 22 by 4 whole to the power 3 by 2 minus, if we put the lower limit, 13 by 4 whole to the power 3 by 2, and you see in the denominator 4 to the power 3 by 2, it means 2 to the power 3, which is 8. So we have 8 in the denominator here, and we have 8 in the denominator here, so these 8 and this 8 will cancel. Now we have 1 by 27, 22 to the power 3 by 2, and we know x to the power 3 by 2 equal x root x. So 22 to the power 3 by 2, we can write 22 root 22 minus 13 root 13. So you can put your answer here, or you can approximate it by using your calculator. That will be 2.09. So the length of this curve from 1 1 to 2 root 2 will be 2.09 units long. Now let us try to solve the same problem by using our second formula, which is integrating with respect to y. So y equals c to y equal d, and here it will be dx by dy integrating with respect to y. So in order to use this formula, we need to convert this equation into x equal to function of y, that will be y to the power 2 by 3. So dx by dy will be 2 by 3 y to the power 2 by 3 minus 1, which is equal 2 by 3 y to the power minus 1/3. So the square of dx dy will be 4 by 9 y to the power minus 2 by 3. So let me put this result here, and y start at 1 and at 2 root 2. So y to 2 root 2, 1 plus 4 by 9 y to the power minus 2 by 3 square root dy. And here first you need to simplify it. and that will be, if you simplify it, it will be 1 plus 4 by 9 y to the power 2 by 3 dy, and this equal 1 to 2 root 2, square root is here, square root of 9y to the power 2 by 3 plus 4 divided by 9y to the power 2 by 3, and this equal 9. If you take it out of this square root, then it will be 1 by 3, and if you take again y to the power, you see 2 by 3, if you square it, it will be y to the power 1 by 3. So if you take it in the numerator, then you will get y to the power minus 1 by 3 root 9y to the power 2 by 3 plus 4. So now we can use u substitution here. Let's say 9y to the power 2 by 3 plus 4 equal to z. Therefore 9 times 2 by 3 y to the power 2 by 3 minus 1 dy equal dz. This equal 18 by 3 y to the power negative 1/3 dy equal to dz. Therefore y to the power negative 1/3 dy equal 3 by 18 dz, which is equal 1 by 6 dz, and the corresponding limit will be z, y and z. When y equal to 1, z will be what? When y equal to 1, z will be 9 plus 4, it means 13, and y equal to 2 root 2, then z will be what? 9 2 root 2 whole to the power 2 by 3 plus 4, 2 to the power 3 by 2 whole to the power 2 by 3 plus 4. This equal 18 plus 4 equal to 22. So when y equal to root 2, z equal 22. So let me put this result here. In this integral we have 1/3 13 to 22 y to the power, this one is equal 1 by 6 dz. So root z 1 by 6 dz, and which is equal 1 by 18 13 22 root z dz, and this equal 1 by 18 square root of 13 to 22 root z dz, which is equal 1 by 18 z to the power half plus 1 3 by 2. So I can write 2 by 3 here, 13 22, this equal 1 by 27. If you put the upper limit, you will get 22 root 22 minus 13 root 13, which is the previous result, 10.2.09. This is the answer. So now let us try to solve example 2. We need to here calculate arc length of this curve from x equal to 0 to x equal to 3. So our arc length formula is this one, a to b 1 plus dy dx whole square root dx, and we are given y equal to 1/3 x square plus 2 whole to the power 3 by 2. So derivative of y with respect to x is equal to 1/3 3 by 2 x square plus 2, 3 by 2 minus 1 into 2x. This is the chain rule. So you can cancel this. So we have x root x square plus 2, because 3 by 2 minus 1 equal to 1/2. So derivative of y with respect to x, we need square x square plus 2, this equal x4 plus 2x square. Now we can put it here, 0 to 3, 1 plus x4 plus 2x square square root dx. So how can we integrate it? We can write this one as 1 plus x squared whole square. So we can cancel square root and 2, and this one 0 to 3, 1 plus x squared dx, which is equal x plus x cubed by 3, 0 to 3. If you put 3 here, 3 plus 27 by 3 minus 0, which is equal 9 plus 27 by 3, which is equal 36 by 3, which is equal 12 units long. So this is the answer. The arc length of this curve from 0 to 3 is 12 units long. Now let's try example 3, and we are given y equal 3x to the power 3 by 2 minus 1. Therefore derivative of y with respect to x is 3 by 2 x to the power 3 by 2 minus 1 minus 0. This equal 9 by 2 x to the power 1/2. So the square of d dx is equal 81 by 4x. So let us put this result here in the formula. 0 to 1, 0 to 1, 1 plus 81 by 4x square root dx. Now we can integrate it by using u substitution or z substitution. So let's say 1 plus 81 by 4x equal to z. Therefore 81 by 4 dx equal dz. And so dx equal 4 by 81 dz. And the corresponding value of z will be when x equal to 0, z will be 1, and when x equal to 1, z will be 1 plus 81 by 4, which is equal 85 by 4. 85 divided by 4. So let me put this result here. 1 to 85 by 4 root z 4 by 81 dz, which is equal 4 by 81 z to the power 3 by 2, our half plus 1 3 by 2, and let me put the opposite one here, 2 by 3, 1 to 85 by 4. So this equal 8 by 243, and 85 by 4, which we can write 85 by 4 root 85 by 4 minus 1. So this equal, you see 2 is here and 4 is here. So we have 8 in the denominator, 8 by 243. So here we have 8 and 85 root 85 minus 1. This equal 8 and 8 will cancel. So we have 1 by 243, 85 root 85 minus 8. So this is the answer, or you can approximate it by using your calculator. So that's all for today, and let me put some homework for you so that you can try in your apartment. And these are the homeworks. Hope you enjoy this lesson and hope to see you in the next one. Thank you very much.